down to just flipping zeros and ones. Computers have become smaller and more powerful at an incredible rate. There's more computing power in your cell phone than there was in the entire world in the mid-1960s. And the entire Apollo moon landing could have been run on a couple of Nintendos. Computer science is a subject that studies what computers can do. It's a diverse and overlapping field, but I'm going to split it into three parts: the fundamental theory of computer science, computer engineering, and applications. We'll start with the father of theoretical computer science, Alan Turing, who formalized the concept of a Turing machine, which is a simple description of a general-purpose computer. People came up with other designs for computing machines, but they're all equivalent to a Turing machine, which makes it the foundation of computer science. A Turing machine contains several parts: an infinitely long tape that's split into cells containing symbols. There's also a head that can read and write symbols to the tape, a state register that stores the state of the head, and a list of possible instructions. In today's computers, the tape is like the working memory, or RAM. The head is the central processing unit, and the list of instructions is held in the computer's memory. Even though a Turing machine is a simple set of rules, it's incredibly powerful, and this is essentially what all computers do nowadays, although our computers obviously have a few more parts, like permanent storage and all the other components. Every problem that's computable by a Turing machine is computable using lambda calculus, which is the basis of research in programming languages. Computability theory attempts to classify what is and isn't computable. There are some problems that, due to their very nature, can never be solved by a computer. A famous example is the halting problem, where you try and predict whether a program will stop running or carry on forever. There are programs where this is impossible to answer by a computer or a human. Many problems are theoretically solvable, but in practice take too much memory or more steps than the lifetime of the universe to solve. And computational complexity attempts to categorize these problems according to how they scale. There are many different classes of complexity and many classes of problem that fall into each type. There are a lot of real-world problems that fall into these impossible-to-solve categories, but fortunately, computer scientists have a bunch of sneaky tricks where you can fudge things and get pretty good answers, but you'll never know if they're the best answer. An algorithm is a set of instructions independent of the hardware or programming language, designed to solve a particular problem. It's kind of like a recipe of how to build a program, and a lot of work is put into developing algorithms to get the best out of computers. Different algorithms can get to the same final result, like sorting a random set of numbers into order, but some algorithms are much more efficient than others. This is studied in algorithmic complexity. Information theory studies the properties of information and how it can be measured, stored, and communicated. An application of this is how well you can compress data, making it take up less memory while preserving all or most of the information. But there are lots of other applications. Related to information theory is coding theory. And cryptography is obviously very important for keeping information sent over the internet secret. There are many different encryption schemes which scramble data and usually rely on some very complex mathematical problem to keep the information locked up. These are the main branches of theoretical computer science, although there are many more that I didn't have time to go into, like logic, graph theory, computational geometry, automata theory, quantum computation, parallel programming, formal methods, and data structures. But let's move on to computer engineering. Designing computers is a challenge because they have to do so many different things. Designers need to try and make sure that they're capable of solving many different kinds of problems as optimally as possible. Every single task that runs on a computer goes through the core of the computer, the CPU. When you're doing lots of different things at the same time, the CPU needs to switch back and forth between these jobs to make sure everything gets done in a reasonable time. This is controlled by a scheduler, which chooses what to do and when, and tries to get through the tasks in the most efficient way, which can be a very difficult problem. Multiprocessing helps speed things up because the CPU has several cores that can execute multiple jobs in parallel, but this makes the job of the scheduler even more complex. Computer architecture is how a processor is designed to perform tasks, and different architectures are good at different things. CPUs are general purpose, GPUs are optimized for graphics, and FPGAs can be programmed to be very fast at a very narrow range of tasks. On top of the raw hardware, there are many layers of software written by programmers using many different programming languages. A programming language is how humans tell a computer what to do, and they vary greatly depending on the job at hand, from low-level languages like assembly through to high-level languages like Python or JavaScript for coding websites and apps. In general, the closer a language is to the hardware, the more difficult it is for humans to use. At all stages of this hierarchy, the code that programmers write needs to be turned into raw CPU instructions, and this is done by one or several programs called compilers. Designing programming languages and compilers is a big deal because they are the tool that software engineers use to make everything. So they need to be as easy to use as possible, but also versatile enough to allow programmers to build their crazy ideas. The operating system is the most important piece of software on the computer, as it's what we interact with, and it controls how all of the other programs are run on the hardware. And engineering a good operating system is a huge challenge. This brings us to software engineering, writing bundles of instructions telling the computer what to do. Building good software is an art form because you have to translate your creative ideas into these logical instructions in a specific language, make it as efficient as possible to run, and as free of errors as you can. So there are many best practices and design philosophies that people follow. Some other important areas are getting many computers to communicate and work together to solve problems, storing and retrieving large amounts of data, determining how well computer systems are performing at specific tasks, and creating highly detailed and realistic graphics. Now we get to a really cool part of computer science, getting computers to solve real-world problems. These technologies underlie a lot of the programs, apps, and websites we use. When you're going on vacation and you want to get the best trip for the money, you're solving an optimization problem. Optimization problems appear everywhere, and finding the best path or most efficient combination of paths can save businesses millions of dollars. This is related to Boolean satisfiability, where you attempt to work out if a logic formula can be satisfied or not. This was the first problem proved to be NP-complete and so widely considered to be impossible to solve. But amazing development of new SAT solvers means that huge SAT problems are solved routinely today, especially in artificial intelligence. Computers extend our brains and multiply our cognitive abilities. The forefront of computer science research is developing computer systems that can think for themselves, artificial intelligence. There are many avenues that AI research takes, the most prominent of which is machine learning, which aims to develop algorithms and techniques to enable computers to learn from large amounts of data, and then use what they've learned to do something useful, like make decisions or classify things. And there are many different types of machine learning. Closely related are fields like computer vision, trying to make computers able to see objects and images like we do, which uses image processing techniques. Natural language processing aims to get computers to understand and communicate using human language, or to process large amounts of data in the form of words for analysis. This commonly uses another field called knowledge representation, where data is organized according to their relationships, like words with similar meanings are clustered together. Machine learning algorithms have improved because of the large amount of data we give them. Big data looks at how to manage and analyze large amounts of data and get value from it. And we'll get even more data from the Internet of Things, adding data collection and communications to everyday objects. Hacking is not a traditional academic discipline, but definitely worth mentioning, trying to find weaknesses in computer systems and take advantage of them without being noticed. Computational science uses computers to help answer scientific questions, from fundamental physics to neuroscience, and often makes use of supercomputing, which throws the weight of the world's most powerful computers at very large problems, often in the area of simulation. Then there is human-computer interaction, which looks at how to design computer systems to be easy and intuitive to use, virtual reality, augmented reality, and telepresence, enhancing or replacing our experience of reality. And finally, robotics, which gives computers a physical embodiment, from a Roomba to trying to make intelligent human-like machines. So that is my map of computer science, a field that's still developing as fast as it ever has, despite the fact that the underlying hardware is hitting some hard limits as we struggle to miniaturize transistors anymore. So lots of people are working on other kinds of computers to try and overcome this problem. Computers have had an absolutely huge impact on human society, so it's going to be interesting to see where this technology goes in the next 100 years. Who knows, perhaps one day we'll all be computers.
Good afternoon, everybody. Welcome to our first series of Career Insider. My name is Brian Law, and we are very glad to have all of you here today. As you saw in the video just now, today we are going to discuss about computer science. So why Career Insider? Basically, what we are going to do is we want to give you a lot of insights about a particular career, and it helps you make the kind of further study decision and that you are about to make in the future. And I believe there are a lot of viewers here today that are students who could just completed your SPM or your pre-U, or there are teachers or parents around. Maybe you can just leave a comment in the comment section and let us know, what are you? Are you a student? If you're a student, just put student. If you are a teacher, just put teacher. If you are parents, just put parents. All right. So we are streaming live on both platforms, on our Study Hub Student Advisory platform and also MyDigitalMaker with MDAC. So we hope both on audience on both platforms, what you can do is help us like our page and also share our stream for today. And today it's a very special day because we are all locked in lockdown mode, MCO. We are all at home. We're not allowed to travel more than 10 km because of the COVID situation. Our MCO is also being extended further to 12th of May, and I believe it may extend even further. And it really makes the discussion today so ever so relevant, because we are relying so much on technology today. You know, from ordering food, you order through a delivery app, or you do your schoolwork using Google Classrooms or the e-learning apps. And also you get your groceries through grocery shopping apps. And even our interaction here today, we are on Facebook, a social media live interaction. And all of this, it's going to be the new normal, and which is why it is ever so relevant, you know, to be discussing about technology as a career and as a choice of further studying. And today we have a very interesting guest with us here. His name is Kenneth. He is the technical director with Alsid. Alsid is a startup based in France. And you may not hear of it because it's a cybersecurity company. It's not a consumer-based technology. And it's not like so it's not like a very household name, like, you know, you heard of Grab, you heard of Lazada, Shopee, you know, that kind of startup. But Alsid is very popular in France, and Kenneth is also previously a engineer with Microsoft. Okay, so his area is in technology, of course. He's the technical director, and he will be sharing more with us on his experience in his 10 years working in tech, and also his experiencing studying in tech. So let us welcome Kenneth. Give us a
Hey,
lot of likes and love, likes and love, likes and love, as you know, as your claps, virtual claps. All
hey,
right, hi
Brian.
Kenneth, how are you?
I'm good. Thanks for inviting. Very honored to be here.
All right, thank you, Kenneth. So maybe Kenneth, you can share a little bit about yourself with us.
Yeah, sure. My name is Kenneth. How I came here, as I graduated from University of Malaya. I joined Microsoft right out of college. I worked for about 6 years in Microsoft. And as Brian has introduced me just now, I was a field engineer in Microsoft for about 6 years. And then I changed my job. I got a pretty nice opportunity to do cybersecurity in the current company that I'm in. It's a French-based enterprise cybersecurity company, and as Brian rightly said, it's not consumer-facing company. It's more like an enterprise-facing company. That's why you may not heard about it. But yeah, so basically, I'm working cybersecurity, which is my forte right now.
Interesting, thank you, Kenneth. And you did mention that you did computer science in University of Malaya,
Yes, I
right?
did. Yeah,
How
exciting
many years
time.
ago?
Oh wow, that will reveal my age. But I did that, I would say maybe 8, 9 years ago.
Yeah. Okay.
When I graduate.
Yeah.
Yep.
So maybe you can briefly share with us, what is it like to study computer science? Because I think there are a lot of students, who registered their interest with us, right? A lot of them mentioned computer science. I want to do computer science,
Yep.
and like. And as all of us know, computer science, or one of the requirement is at maths. You need to be strong in maths. But can you give us an insight and overview? What kind of maths is it, or in computer science? What is it like? Yeah.
Yep. So the mathematics and what we did in computer science is very theoretical. There are some hands-on, obviously, but the mathematics itself is more like it's very different than STPM. And honestly, I would say it is a little bit easier than STPM additional mathematics. But yeah, so that's what I can share right now in terms of those courses. But what you will learn is more about logics, how to apply logics in mathematics, and as well as sometimes you would learn about, in computer science, you'll learn about ethics as well, which is one of my favorite courses, because especially in the age of AI, you would want to know what type of moral decisions an AI could make. So beyond mathematics, there are obviously a larger field of different things that you can learn in the courses at University of Malaya, I would say.
Right. What was the when you say about computer science, and when we talk about studying a degree, there are a lot of subjects in the degree, right? What was the toughest subject you can recall of in your computer science degree?
Well, let me think. I think one of the things that I cannot really relate to back then was a subject called logic. And it's not like logic gate. It's not physics logics, right? It's more about fallacy. It's more about different type of fallacy, such as straw man, such as those kind of argumentative logics. It may seem odd to you, but it is very important for a computer scientist to master that particular skills in different ways, and it's applicable to different area in your life as well. So it could be in your career when you require logic in your maths, or it may require you to think about how you write certain programs. Yeah.
Okay. Well, before we move on any further, I would like to actually remind all of you, audiences here today, whether you are a previous student or after SPM student, we actually have, please stay tuned until the end of the web series today, because we will actually open up a coaching opportunity with Kenneth. It's a one-on-one coaching opportunity. So, and everything is done online. So we will actually choose one student, who has expressed the most interest to us. So if you want to be chosen, please make sure you stay until the end of the stream, and also please ask us any questions. So this is a chit chat session, right? So you can ask us basically any question along the way, and we will address it. Yeah. So if you have any questions, you don't have to hold it back. You can just right away put down your questions in the comment section. Yes. So Kenneth, back to computer science, right? Back to the area of studying computer science. I mean, in the field, in the education system today, you did computer science, and there are actually other fields that is also very popular if we are interested in technology, right? And the other one is IT, information technology, right? Degree in IT and degree in computer science. Which one should a student choose?
Oh, well, it depends, I would say, what is the area of interest of a particular student. And some may say it's a little bit too early for you to think about it. And I agree, right? When I was your age, right before going to university, I have no idea what I want to be or where I would become, what I would become in the future. But if you're having this type of questions and dilemma in your life, there's like a very small advice that I can give you. It depends on what you really, really like to do. If you feel like you prefer to sit in and do a series of research, how to make computing easier. If you look at AI, how do you make AI smarter? Or if you look at self-driving cars, how do you make self-driving cars safer? Those are the computer science field, I would say, is more related to computer science. It's not 100% related to computer science, but it's more related to computer science. But if you think about, if you would like to help about how to make, business size of computing, such as how do I make a retail like Grab a better improve the processes of certain business processes. How do I make retail easier? How do I make my boss's job easier, and etc. in a particular company? Then IT will probably align you more in that sense. So in a nutshell, I think IT is more about business processes, creating a better environment for business to thrive, whereas computer science is more about making computing such as AI, self-driving cars, or performance of the particular applications better.
Yeah, that I think in short, what you mentioned is computer science is actually more theoretical, and IT is more application based, using existing software to assist a business.
Yep,
right?
I would say it's like applied mathematics and pure mathematics.
Okay, applied mathematics and pure mathematics. Just an interesting observation, right? Like for example, in the States, most of the technology-related graduates are actually computer science graduates. Yeah, and I think IT degree is not very popular in the States. I do not know why. Yeah.
Yep.
So
I don't think it's offered much in the States. And if you look at some of the popular university in the States, IT is actually offered in their business college, or in Malaysia we call it faculty. But in Malaysia we offered IT in the computer science faculty. So that is slightly, I would say, differences what you will see. And obviously, if you study business in a business college in Harvard, you wouldn't major in IT in that particular college, right? You probably major in business administrators. But if you're in the MIT studying computer, you won't necessarily go to IT. You probably going to go for computer science because that's probably the most popular courses over there.
That's right.
So I think there's a difference between how we offered and structure our courses in Malaysia and how other universities structure them.
Yeah, I think there's no right and wrong here, but it depends on really what you are truly interested in. Yeah, that's just a very interesting observation you had there. So, back to your work. I think we are all very interested to know, after studying a 3 to 4 years computer science or IT degree, and then you come out to work, you want to get into a tech career. What do you actually do in Alsid as a cybersecurity company? Yeah.
So I do a lot of different things, and as a pretty small company with very small amount of people we can actually mobilize. I do things that is sometimes out of job scope as well. So I talk to like CIO, or what we call as a Chief Information Officer, or CISO, Chief Information Security Officer, and understand what's their pain point, if they are under attack, certain cybersecurity attacks, what are they trying to do, how we can help to prevent those cyber attacks from happening again. So those are one portion that I'm doing. The second one is obviously to talk to the people that is interested with Alsid, and to tell them how we assist their current structures, how we can integrate with their environment to protect them against what we call as malicious actor, as in hackers, in a layman term, how we solve those type of different problems that each enterprise are facing. So that's my day-to-day job. Briefly.
So does that means you come across or you deal with hackers a lot?
Not necessarily on a direct basis, but I would say most hacker would heard of Alsid, because what we do is in direct contrast to what they are trying to achieve as well. So they are trying to steal data. We are trying to prevent those data from being stolen. So we don't we don't take a gun and shoot each other, but on an indirect, on a proxy basis, we have that. Yeah.
Like you have your terminal and they have their terminal, that kind of thing.
Correct. Yep.
Yeah. Okay. So all right, we actually have a question here by Ayman Humaira. Yep. So how does it differ to software engineering? I think, Ayman, are you speaking the differences between software engineering and computer science? Yeah.
Yep.
Yeah. So
the question is, what is computer system? Is it the general computer science?
okay.
Yeah. Good questions. If I were to be honest with you, I don't know. But I can try to answer it. But take my answer as a very small pinch of salt. So basically, computer system is about what structure as a computer system is more towards operating system. So they would figure out how do a computer system works with the RAM, with the graphic cards, how the RAM, what is the responsibility of the RAM, what is the responsibility of the graphic card, what is the responsibility of CPU, and then you go into the CPU itself, and then to figure out how the CPU works with all the silicon inside, right? How can a simple 1-0 showing graphics right now in front of your monitor, right? So those are computer system. That's what is teaching right now. And then in a more general terms, computer science, it's more broad. It covers more things. It covers such as how do I write instructions for the computer to understand, and how can I make the instructions easier to be understandable or faster to be processed by the CPU. Right, so that's a very total different fields. And then if you go further into it, then they will tell you how do you create artificial intelligence in computer, and the different things that can come up with as well. So very totally different fields.
And how does it differ to software engineering? I mean, computer science and software engineering, to your understanding.
Yeah. So software engineering is how if you go into software and computer science, you would start to create software, right? And we'll take the most popular software that you have, like Facebook. And Facebook is fast, as you know. You can just press an app, and then Facebook just pop up and show you all the friends updates that you have. Now, beyond the scene, it's a very complicated things. You have databases. Database can be relational database or non-relational database. And then you have grids, and then you have how do you make Facebook fast? How do you make Facebook have a live stream that doesn't lag at all? How do you combine all these things, different things into a particular app, and how do you structure them into one single software? That's basically engineering. And if you take something that you use on a daily basis, like a car, right? So a car have a wheel, you have a steering, you have your engine, you have your blah, blah, blah. So if you take those apart, they are basically mechanical engineer, right? So they so it's an individual mechanical engineer. But then if you you put them together, that's basically the hard part. And I wouldn't say the hard part, but there's more, the different part of it, which is the engineering side of it. How do you combine different things to make a efficient solution? Yeah. Right. So software engineering, in a nutshell, is to combine different things, engineer it to the consumer for the consumer use.
Computer science is more broad, more fundamental, right?
Yep.
And software engineering is directly focusing on creating softwares that solve day-to-day problems for businesses, for individuals, etc.
Yeah, because in the software, you have a lot of modules. You have database, you have the graphics itself, you have the logic itself. So the engineer is like an architect. But there's a different field called software architect as well, which we're not going to touch. But yeah, so roughly it's like that. And to give you some context, how structured it back then is that in the computer science of courses, you have software engineer, you have artificial intelligence, major in artificial intelligence, major in software engineer, majoring in networking, and I think the last one is major in IT as well.
So right now, UM has major in AI as well.
Yep.
Yeah, right. So it's a very interesting context. So if you are interested in computer science, and disregarding which university that you are interested into, you should actually find out what their major is, because I think the major is going to put a focus on in your studies. And if you can find the major that you are interested in, that would be extremely good. And I think getting into UM's computer science today is also not an easy job right now, because last we checked, the past results was all 4 flats for matriculasi. Regarding your immatriculasi or STPM, is 4 flats required into computer science. Yes. So how about let's go back into how are you, Kenneth? How are you relating what you have learned in computer science in your degree, right? And how do you actually apply into your work today?
So I think a lot of people can relate when I say a lot of things that you learn in schools, you don't necessarily know about them or remember them anymore, which I think is kind of true. But I wouldn't say I wasted my time studying in the university. I studied I studied a lot of different skills, skills such as how do you apply the skills in your day-to-day job. For example, how do you solve certain problems using mathematics? Although I'm not using algebra on a daily basis, I don't necessarily need to use algebra, but the concept of solving algebra is very important, because you have a problem with algebra, but if you don't know how to solve it, and your brain is not wired to solve it, then you probably have a hard time in real life, right? So I would say, even though right now you don't see the usage of learning this type of things in the uni or in STPM or SPM, but there's an intangible skills that you are indirectly learning as well, how to solve something efficiently. So and those are lifelong skills that you will keep for the rest of your life.
Yeah. And I think at the end of the day, when we go into university, what you are choosing is your major, is your expertise, but also there are other skills that you can learn. Those are people skills, skills working together, how to work together with other people, how do you build your character. I think those are the things that we shape while we are in our years in varsity. We need to accept the fact that we may not be the smartest in class, and how do we identify our own strengths. So I think what Kenneth explained is, in a nutshell, is it everything you learn in a degree is applicable, or in computer science is it applicable in today's world? Maybe not everything, but what is definitely applicable is your life skills, is your character. Yes.
I mean, in the school, you would have group projects, and you don't see the point of probably doing a group project. And sometimes, especially for a computer science students, mostly, I'm not trying to generalize, but mostly we are pretty introvert and self-sustainable, and we like to do things our own, right? And then you don't see the point of doing group projects. And I have the same thinking as well. I can do it myself better instead of working with other people. And the fact is, when you go out into the job market, you will have to work with other people, definitely.
That's right.
And that would be a skill that you learn in the universities to get you a head start. How do you deal with people in a group settings? How do you deal with people in the meetings that you don't agree with, and stuff like that? So those are important soft skills that you definitely learn in the
That's right. That's right. So before we continue any further, for those students or for those audiences who have just came into our live stream, welcome. Kindly like and share our stream today, and please stay until the end of the stream, because we are actually opening up a coaching session with Kenneth. So one of the students here today will be able to win a coaching session with Kenneth. It's a 1-month session. It's done entirely online, so you can basically ask Kenneth anything, and Kenneth will help guide you into the career that you want to. So, Kenneth, you were previously from Microsoft, one of the largest company in the world. Yeah.
Mm-hmm.
Microsoft, I think late last year, Microsoft achieved market cap of $1 trillion US. Yeah, they just joined the $1 trillion club. So how was it like, working in big tech companies in Malaysia?
It is, well, honestly, I was fortunate enough to
Yeah.
join straight out of college, a big tech company, and I wouldn't have the necessary data point to compare with other company, but I would say it is a great experience. And today, if you ask me the questions again, I would say there's no regret to join such a huge company. And the reasons are simple. The resources that you have in a trillion company, not like in terms of money, but the learning resources that you have, the amount of smart people that you see in the company, and the lifelong friends that you make and smart friends that you make in the company as well, make it all worth it, right? So that's one part of it. And then in Microsoft also brought me to different locations as well. And that's because it is a global company, and employees are expected to go out from their home base to get trained in the States, or conduct business meeting in the region as well, Thailand, Indonesia, Philippines, and whatever. So I would say that was very fortunate for me. I've never been out of Malaysia except Singapore until I joined the company itself. I have the opportunity to learn. And the cultural and people diversity that you see when you travel would open up and change your worldview as well. How the West think versus the East, what is the differences in thinking, is also something that you will learn throughout your life.
Cool. Apart from, I think, Kenneth, you had the opportunity while working with Microsoft. I think you have traveled to many parts of the world, right?
Yep.
America, other parts of Asia. What are the other perks, that you get to have while working in such a big tech company like that? Yeah.
Perks such as infinite amount of learning resources you have. If you go online and see Microsoft certification and stuff like that, there are tons of people that wants to get Microsoft certifications, right, to prove their worth and their skills. And within Microsoft, you get to do it for free for your own knowledge, unlimited number of it.
Wow.
And you also get to interact with the people that created Windows, the team that created Xbox, and the team that created your favorite product. And you get to interact with them when you go to the corporate headquarters. You can set up meetings with them. And most likely, I wouldn't say 100% of the time, but most likely they would be willing to spend time with you. And I think that is one of the intangible perk that you will get as a person out of Microsoft. You can't just approach someone, and ask, "Hey, you created Xbox, can I talk to you?" So it's not very possible.
Yeah.
But I think that's some of the perks that I had the opportunity to use when I was there.
Wow. Yeah. Imagine you get to, speak to someone, understand their thinking process behind someone who created Xbox.
Yep.
Yeah. Wow.
Yeah. A lot of geniuses in there as well. I would say one of the perks is basically to be able to pick their mind, see how they think, how they got here.
Do you get to see their secret R&D?
No. So that's you can actually go to the lobby, but you cannot go further than that. So there's a building called Studio X, I think, if I'm not mistaken.
Yeah. Where is this? Is in headquarters Seattle?
Yes, in Redmond, in Seattle, Redmond, Washington. So
Okay.
there's a Studio X. They name it Studio X, and all this highly confidential design of Xbox and computing all there. Apparently, rumors say Surface was born there as well.
Okay. Interesting. All right. So I think this question, many students here listening to us here today are very interested in. Yeah. So I just want to ask you very bluntly: do working in tech get paid well?
Yes, I believe so.
Yeah.
But I would say there would be opportunity for every field to be paid well. And it is not worth it if you get paid well, but you don't enjoy it. You would be burnt out sooner or later. You
That's
can earn 5-figure for the first 5 years,
Okay.
but you absolutely hated it.
Okay.
But
Yeah.
in long term, it's not going to be sustainable. But to answer your questions, yes, I believe tech company does pay well, and it is supported by different type of statistics and analysts as well. And it's an enjoyable for me to do so, and I think that's very fortunate for me as well.
Can you give us like a hint, approximately, as a fresh grad, what is it like? I'm trying to dig more insights for our listeners here today. So
yeah.
if you can't say it, publicly, it's fine. But maybe, yeah.
Yeah, I mean, I would say Microsoft. Let me use some sort of computer science statistics. I mean, it's not computer science exactly. Statistics. If you look at a bell curve, I'm sure you know bell curve.
Yeah.
Right. So there's a middle point, and then there's a top tier paying company, and then there's lower end, and then there's an average. Look at the bell curve. Right.
That's right.
I would say Microsoft pay the fresh graduate at the end, the top 1% quantile. So basically, you can expect Microsoft to pay the top dollar compared to the bottom 99% of the company in Malaysia. So that's something that I can share with you.
Okay.
And also, if you look at Glassdoor, Glassdoor fresh graduate income for Microsoft Malaysia is pretty accurate as well.
Oh, okay. Yeah. Don't go to Glassdoor now. Go later, okay? Because we still have more interesting content for you today. So yeah, that's interesting. So how about let's look into some of the comments from students. There are actually a lot of questions. So there's a question from Alicia Shera. Is it easy to find jobs with computer science course? What we can be other than a programmer? Yes.
What we can be other than programmer. Well, Brian, maybe you can help me with how easy it is to find job. I think you have more knowledge on that.
That's right.
But what can we be other than programmer? I would say programmer is very, very, very just one particular things that you can do when you go into computer science. I have people and colleagues and friends that went in computer science and ended up doing not doing programmer. I can give you some example, right? So they ended up doing perhaps the technical account manager in Microsoft. So those are some of the things that does more like a business development role as well in Microsoft that you can choose to do. And people are just afraid that going into computer science means I have to be programmer. And sometimes it's a little bit too much for a lot of people, and it's probably too much for me as well. I don't necessarily want to be a programmer, right? But computer science, you ended up have a more leverage if you want to join a big tech company. If your goal is not Microsoft, maybe it's Google, right? And Google, I would say there is no programmer job in Google Malaysia, right? It's more like how do you assist customers in using analytics to achieve a business goal, right? Having a computer science degree would be very helpful for you to land a job like that. Using analytics technology from Google to help a small SME to achieve business growth, right? So there are a lot of things that you can do other than programmer.
That's right. I mean, just to add on to what Kenneth has mentioned, because in computer science, you are being trained to think analytically and with a logical thinking, right? So there are actually a lot of business consulting firms out there that loves to hire computer science and engineering graduates. Yeah, so it's not necessarily if you are doing computer science, you will be bound to be a programmer and forever. No, it's not just that. Yeah, so maybe to address on the issue of are there, how to say, where was the question again? Is it easy to find jobs with computer science course? Okay, let me just give you this perspective. So in our last stream, we actually also mentioned, we also shared a LinkedIn statistic. So this is a LinkedIn report, a report developed by LinkedIn for Malaysia. So he did mention in year 2020, the top 10 emerging jobs, 7 of the top 10 emerging jobs are actually tech-based. So you can just imagine on that. So emerging jobs, that means more and there's a surge in demand for this kind of job. So for sure, this is not 1997, it's 2020 right now. There are so many companies out there that requires technology, digital skills, and even with in addition to right now in our MCO condition, digital skills is definitely needed. Yeah. So yeah, I mean, Alicia, I hope that answers your questions. Okay. So let's maybe move on to another question. Okay. By Zaki. Zaki says, can I take diploma in science computer if I don't take computer subject in school?
Yeah, definitely.
Yeah, definitely.
Yes,
I
definitely.
don't think I think how's it?
Only the
Kenneth, back
vocational
then, you
schools
don't have,
offer computer
right?
subject, I think. Yeah.
I think back then you don't have computer subjects when you were studying in
We
STPM.
do, but it's not something that you have to take exam for.
That's right. That's right.
Unless you go to vocational school,
Yeah.
we don't. They don't necessarily offer computer
Yes.
subject in high school.
And also the subject science computer have only just been introduced in recent years. I think in the past 4 years, 5 years, they have just introduced it. Yeah. So to address your question, Zaki, nope, you don't need computers subjects. But if computer science, I think the minimum requirement is actually your math subjects. Yeah.
Yeah.
And to get into a Malaysian university, it's also the other subjects that it requires you to pass, which is your sejarah and a credit in your PM. So I hope that addressed your questions too, Zaki. So back to Kenneth, right? So so as a student, there's a lot of students listening here. I mean, just look at the sheer amount of questions, right? So what can the students do right now during this MCO period to get a head start in tech careers?
Yeah. So right now, if you are free, I would say back then I wasn't fortunate enough, but I think right now, with the ubiquitous access of technology and websites and internet and whatever, it is very easy to find things and occupy your time with. And before you go into the uni, what you can do right now during MCO is, I would say, the most productive things is to get skill up, right? Take something that you are interested with, like programming, for example, and go to edx.org or Coursera or whatever online offering websites that they have, and they have free courses for you to learn computer science, mathematics, logic. And if you feel like going into uni in July and doing computer science, you don't want to get started so soon. You want to do something relaxing. There are definitely some other things that relaxing as well. And what I find interests me at the moment is computing ethics, right? Or what we call as computing justice. How do you create justice in computers? How do you create ethics in computers? And I think one of the most popular question is, if you are in a self-driving car, right? Would you want the self-driving car to protect the driver or to protect the pedestrian, right? If there is a junction on the road, and for the self-driving car to choose to either kill the pedestrian and save the driver, or kill the driver and save the pedestrian, what would the car needs to do, right? In those sense, what is a morally correct decisions that the car can make? And I believe those are some of the questions that is very interested and also very light-hearted as well. It's not like doing mathematics and you need to think and use a lot of brain cells power. And there are a lot of possibilities that you can do during this period.
Yeah. So wow, I think the team Elon Musk is building right now is also answering that question to whether to protect the driver or to protect the pedestrian. I think that's a really tough question to answer because of both lives on both sides. Yeah. So we also look into let's say when we go to further study, and there are a lot of reports that mention, you spend 3-4 years of your degree in uni, and the time you graduate, what you learn in your first year or second year may not be relevant anymore, right?
Mm-hmm.
So what do you think is the area of technology, and which area of technology do you think is the future? Kind of. Yeah.
Well, I would say
there's so many, right? Yeah.
Yeah. I would say the Internet of Things,
IoT. Okay.
IoT, and AI would probably be one of the few things that the future would see and would probably gaining tractions and continuously to gain traction as well without slowing down much. And if you think about it, it makes sense because of the power of computing right now allows different ways an AI can discern information and also to generate new ideas that is not possible back then with primitive IT technology.
Wow.
And IoT as well. Computing is getting cheaper. Hardware is getting cheaper. It's getting cheaper to have a chip. Raspberry Pi, if you're interested to have some personal project, costs you about $10, and you can get like a personal computing to program whatever you want, which is pretty cool. So I think to answer the questions, Internet of Things and AI would probably be the future. Yeah.
These two.
Yeah, and it's a personal opinion. I'm not Bill Gates.
Yeah, of course. We're just taking personal opinions, but I do agree to some points. Yeah, Internet of Things. But even though we have been talking about Internet of Things for a very long time, I think for the longest time since like 6-7 years ago, we talk about Internet of IoT. But I think the implementation in Malaysia is probably still low. Yeah, and I think the adoption could be an opportunity for students out there. I mean, for Internet of Things, it can be just a hobby, right? It can be a hobby where you pick up Raspberry Pi. It's related to robotics. It's related to hardware hacking. Yeah.
You probably don't see it because it's relatively small, and day-to-day job you probably ignore it sometimes. But you would see it if you take notes, you see it, right? For example, some of the buildings right now are equipped with IoT sensors to make sure that they are energy efficient. If there's not many people in the building, the sensor will detect that and then to readjust the temperature and to climate and to readjust the climate inside the building as well. Those are sensors, and sensors are defined as IoT as well. And cars nowadays are getting more intelligent also. It's connected. And there are IoT inside the cars as well. So as we go, you will see IoT in more places.
Right. Okay. So Kenneth, because you worked in 2 different companies before for the past 9-10 years.
Yep.
Yeah, and two of these companies are very different. One is a $1 trillion company, Microsoft. Another is $100 million company. Yeah.
Well, the latest evaluation, I think, is about 100. Yeah.
About 100. Yeah. I did my homework. Okay. So these are two different companies, right? One is really big, and one is not to say small, but it's relatively small compared to a $1 trillion company. What differences do you see from there?
Yeah, so the major one is the number of employees. Microsoft has about 100,000 employees. I can't even remember the exact number, but it close to 100,000 full-time employees.
Okay.
Not to mention there's like contractors as well. If you count everything, it's like 300,000 employees, right?
Wow.
About that. So in my current company, we have about 50 employees. So that is a drastic difference.
Okay.
Obviously, with such a big company back in Microsoft, you as a person, as an employee, you get a very specific role and do a very specific things. You don't have to worry about marketing. You don't have to worry about selling the product. You have to only just want to do your job, and you do it right. And it's great. I learned a lot of things from there. And as a fresh graduate, you sometimes need those structures to make sure that you stay on point and you can succeed in your career, especially during the first 2 years of your fresh graduate life.
Right.
Some people liked it, and some people will choose to stay in that point, which is fine. There's no right and wrong. But for me, I decided to change into a different company, a smaller one. And in a small company, it's very different. And when I first joined, it doesn't have any fixed job scope. And they tell you, we can hire you as a technical director or whatever. But eventually, you have to figure out what you need to do to bring the company into the market to ensure that the company can succeed as well, whether in charge of the marketing, in charge of making sure there's a webinar and allow people to know about the brand, even find translators to translate our contents and the product itself. Also part of my role back then as well. So if you like to do different things at the same time to keep yourself interest, and that's something that I enjoy as well. And that's fine. I mean, but that's the difference between a multinational company with a proper structure, with a new startup that is still trying to establish their internal culture, which we currently still are trying to figure out what is our culture and what we want to be as a company. Yeah, but Microsoft, it has their own culture already,
That's
right? And it's very hard if you want to
they
change
hire
it.
consultants to help shape their culture and see what is the most efficient culture that they can do.
Yeah.
So I think essentially the big companies have a very fixed way of doing things, and that's not necessarily a bad thing because it provides you very clear guidance. This is what you need to do. Yeah. And
clearly, it's working well for a multi-trillion cost company.
Yeah. I mean, it's proven to work very well. The share market has told. The market has told them that it's very well. Yeah, the sales has told them it's very well. And I mean, a smaller company, $100 million really is not a small company, but you get to like what Kenneth said. You really get to explore different kind of things. I think you're employee number 1 in Asia, right? Or number 2?
Yes, I'm employee number 1 in Southeast Asia, employee number 2 in Asia Pacific.
Wow.
Yeah. It's a great learning because as a very, very early employees, you get to define what the company will look like, what you want the company to be. And it's an important learning for me as well, because the decisions that we make every day would probably be adopted by the future employees as well.
And from what I know, you are work from home from the day one when you are in a company?
Yes. Well, in Microsoft, I have the opportunity to work from home as well. But right now, I'm fully working from home. We have an office in Singapore, but I don't usually check in the office. But I just work from home. I think it's better. But sometimes I do miss people interaction. It's
like all of us right now, right?
Oh, yeah.
we miss people interaction, right? So Kenneth has been working from home before it was cool. So finally, Kenneth, one very straightforward question. If you don't feel like answering, it's fine. Okay. Okay. With your 10 years in the industry, how much are you currently getting paid?
Okay. Well, I can tell you if you get into what Brian says a coaching session. if you want to know, then you can get into that coaching session. But I would say it's a very comfortable number. It's a very, very comfortable salary that I'm earning, and I'm very humble and fortunate to have the blessing of different people in my life to be in where I am today. Yeah,
that's awesome. So, before we look into the students' questions, let's have a quick fire round of Q&A. So it's just a fun session. So I will ask Kenneth a question, and then Kenneth, you must answer in a split second. Okay.
Okay.
All right.
Let's go.
Ready?
Yep.
Firefox or Chrome?
Firefox.
Windows or Mac?
Windows.
iOS or Android?
Android, 100%. I did start using my first smartphone was actually iOS.
Oh, okay.
Yeah, but
okay. I thought once you go iOS, you won't go back. Well, what's your favorite website?
Reddit.com.
Okay, the homepage of the internet.
Yes.
Favorite gadget?
I would say my Surface tablet.
Okay.
Microsoft Surface. Yep.
Wow, your pro Microsoft answer.
Yeah.
Okay.
Is it that obvious?
Working in Microsoft or working in Alsid?
Oh, very tough questions. Very political. Well, right now in my current life, I would say it's Alsid. But I have no regret, and I may, choose to go back.
Oh, okay.
Yeah.
Okay. All right. Work from home or work in office?
Office. I'm kind of miss office right now. But then work from home has its own perk. You don't have to go and drive, the KL traffic.
So much more efficient, no traffic, everything, right? But I really miss going to office. Okay, last one. Paid well but not happy, or low pay but very happy?
Oh, I'm a very capitalist, monetary focused people, so I would choose money over happiness.
Okay, that's your choice. That's awesome. Okay, so students, audiences, if you are interested in a 1-month coaching session with Kenneth, so please make sure to fill up the link that we will be sending in the comment section shortly. Okay, so this is only open for students. So parents, please, you don't need to be coach. It's only for students. Yeah, and also teachers, sorry, this is only for your students. All right, so if disregarding your after SPM or after pre-U or you're studying degree, you can absolutely join this opportunity. Okay, just fill up the forms that we will be sharing in the comment section shortly. So Kenneth, let's look into some of the questions being asked.
Yep.
All right, so we have a question from Farhana Safi. Will it be fine if I study diploma in IT, then study bachelor in computer science? I think I can help answer your question. Okay, will it be fine if I study diploma in IT and then bachelor in computer science? Number one is these two have a similar nature. Okay, so it's very likely you can. So if it's even better if your diploma in IT and your bachelor is in the same university, then it's very confirmed you can further study into the degree with credit exemption. So normally when you go into your degree, you can straight go into second year or so. But if you go into another university, then you will need to actually check how much exemption you get. But in nature, because it's the same nature, you can absolutely do it. Yeah. So Farhana, I hope that answers your question. Okay. So next, how do people work with a computer science degree work on their own? Ayman Humaira. Question from Ayman.
How does degree work on their own?
Work on their own. I think you're talking about self-employed. Yeah. So I think there are a lot of examples out there.
Freelancers. Yeah.
Freelancers. That's one. Freelancers is in high demand right now. I just read a report during this MCO. Website development freelancers are in hot demand and they are making money actually during this MCO
Yeah, there's a
period.
few websites dedicated for freelancers to find job and for
Yes.
people to post job as well.
Right. Yeah. One is it? It's Fiverr. Yeah.
Mm.
Yeah. So freelancing, and you look at entrepreneurs. There are a lot of computer science, tech-based entrepreneurs. Who did computer science back then, even though they may not graduated. They may not have graduated. Yeah. So I hope that answers your questions. Do you need to be very good in maths in order to master machine learning, Kenneth?
Very good in math to master, and it certainly will be helpful if you have very good mathematics.
That's right.
But I wouldn't say machine learning is just math itself. One thing, it's just one dimension of machine learning. But if you are good at it, it's good for you. But if you not good at it, I believe you can practice, and it's just one dimension of machine learning. Yeah, you don't necessarily have to.
It helps, but it's not
It helps.
necessarily the only thing.
Yeah, so if you're not good, don't give up. Still continue to learn and practice. Definitely machine learning, it's not 100% mathematics.
Right. Also from the same student, Xiang Ge, is being a full stack developer better or more beneficial in different careers?
Full stack definitely commands higher job prospects and salary as well. But at the same time, it is very difficult to be a full stack developers. And what type of full stack you're going to look for? I mean, if you say, again, I'm going to do front end, I'm going to do back end, I'm going to do database, I'm going to do graphic as well, I consider myself full stack. But in each of this technology, you have different subset of technology as well. Let's say you choose to be database. Your database, you have MySQL, you have SQL Server, blah, blah, blah. In front end, you have different type of JavaScripts and whatever.
C#,
so C#, is middleware, whatever. But yes, I mean, definitely if you can be a full stack, it'd probably be okay. But ideally and personally, knowing myself, I don't have the capacity to be a full stack developer. So for me, I would rather just focus on a very specific things at one time and excel in it. Right now, I'm doing cybersecurity, and I'm not full stack at all. It doesn't even consider as a stack, right? But analogically, so I focus on cybersecurity, and really, I would say master something, and you have more capacity, then become a full stack.
That's right. Be really good at it. Unless you have a lot of capacity, then I hope that answered your question. So I think to put in context, for other listeners who don't understand what is full stack means the front end development and also the back end development. So why your favorite website isn't Stack Overflow?
Stack Overflow is sometimes too intense. When a question to ask, what is my favorite website? I think it from personal, not so pressured kind of activity that I want to do, and that's why I consider as a Reddit as my favorite websites. I don't have to go in there with my brain cells all activated. I just go in there and be numb. And Reddit.com is what I want to. But Stack Overflow basically it has a lot of good information, definitely.
Right. Okay. Let's look into Danshin UFO. Danshin. Okay. So his question is, does knowing various programming languages benefit you more, or do you just need to be good in only a single language?
For me, I would say I would do a single language. And when I was in uni, what I learned was Java. And Java is object-oriented programming. And it's important for you to master and know the nitty-gritty details of Java and object-oriented programming. And the reason is if you go to the market and if you find a job, you can easily adapt it to other languages as well, such as C#, right? And Python, because they are both object-oriented programming. And since you already master Java, it's very easy for you to adapt to other languages as well. So at one time in life, it's probably more beneficial for you to know one single and master it. But it doesn't mean that you should not know the rest of the languages as well. But since you master it, you can easily adapt.
That's right. And also a lot of different companies may use different languages for development. Yeah, so some products are based on different languages. So it depends on what company you want to work for too. Yeah.
Mm-hmm.
So
if you want to join Microsoft, definitely C#, Python.
yeah.
Yeah.
And do you know there's actually a full Python tutorial on YouTube? Someone uploaded it. It's 5 hours thing. Yeah. So I mean, students, if you want to learn programming during this MCO, you should absolutely just YouTube Python tutorial. There's a 5-hour session on YouTube. Absolutely free.
Python community is actually pretty awesome.
Yeah.
So
another thing is another question. Is from Devi Morganadas. Okay, from Devi. Is Bachelor in Computer Science Bioinformatics a good course to study?
I can't say for sure whether bioinformatics is something that is a good course to study. But if you like biology, and if you like computer science, why not go ahead and explore it?
That's right. So I think the question really boils down back to you. What is your interest? Why so specific? Why choose something so specific? Yeah. So if you want to,
I can share my colleague that did bioinformatics and become a salesperson.
Okay.
He did bioinformatics and he did actually works in the lab for about 3 to 4 years. I can share his insights to me. I did ask the questions, why didn't he continue to pursue bioinformatics as a career since he spent 4 years in uni. But he basically told me that he's a pretty active person and he likes to talk and he likes to see results almost immediately. So bioinformatics for me is a bit too slow paced. And for example, right? I mean, vaccine is probably a good example for biology and bioinformatics. Maybe not the exact good example, but in order for you to have a vaccine, you have to test animal trial, and to get into animal trial, it takes a few months. Then you go into human trials, few months. If anything goes wrong, you go back to square one. So for him, it takes 4 to 5 years to see a result that he's making in the lab, and he cannot take it, right? That's why he switched career to become a sales for cybersecurity for whatever reason. But yeah, it's boiled down to your interests. What is your personality, and whether you can survive without burning out.
That's right. So Kenneth, it's already 4:02 right now. Maybe we will take one last question. Okay, one last question. It's from Xiangge again. Xiangge, his question is, how can I improve my problem-solving skills? It gives many benefits in computer science, right? So
how can I improve my problem-solving skills? I think it's something that you need to learn on a daily basis. But for me, I learned about arguments and logic. It's something that I invest some of my time in, even on my free time as well. How do you apply logic on your daily conversations? And I think that would help you in problem solving. And there's a few websites that covers fallacies, which I truly encourage you to look for. It will help you in those areas.
Okay. So thank you very much for your time, Kenneth. So
thank you, Brian.
That's it for our session today. We have another live stream session tomorrow at 9 p.m. at night, even though it's 1st of May, Labor Day. Yeah, so it's a Labor Day stream. We are going to speak to Asia Pacific University. It's a premium digital tech university. And you can actually watch the stream at our Study Hub Student Advisory Facebook page. It starts sharp at 9 p.m. So if you are interested in APU, you should absolutely go watch that stream at 9 p.m. tomorrow. So if you are interested to be coached by Kenneth, we have already posted the link, okay, on the coaching session. So what you can do is just fill up the form. We will only choose one student. seriously only one student, you can tap into Kenneth's brain. You can ask him any questions. It's a good way to get insights to prepare you for university and even shape your direction for your future. I hope I had that when I was in Form 6 or Form 5. Yeah. So thank you so much, Kenneth.
Thank you.
Thank you.
Thanks, Brian. Thanks for inviting me.
Let's do a social distancing high five.
All right. How to do this? Whatever.
Okay.
Oh, wait, here. Okay.
Okay. Bye.
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 Oh, yeah.
You must